Hello there, and welcome to Lumen. I am glad you found your way here tonight. Maybe you have had a long day. Maybe you are the kind of person who would rather fall asleep to something strange and far away than to counting sheep. This one is for you. There is nothing to do now but rest. Let your shoulders drop, let your breathing slow, and let the room go quiet around you. Tonight, we are going to spend 2 hours with one planet, and by the end, you will not think of it as the one with the rings. Saturn is the second largest world in the Sun's family, and almost everything about it is stranger than the picture suggests. Its rings are not a solid hoop. They're not even old, and the argument about how old they are is unsettled right now. One of its moons is throwing its own ocean into space. Another has rivers and lakes and rain, and none of it is water. A six-sided shape sits over the North Pole, and nobody has fully explained why. You do not need to follow any of it closely. Each fact stands on its own, so if you drift off and surface again an hour from now, you will not have missed anything you need. Just let it run. If these help you sleep, a like or a subscribe means more people find them. That is all I will say about it. Let us begin with the moon that gave itself away. Enceladus is shooting its own ocean into space, and Cassini flew through the spray. Jets erupt from 4 fractures near the South Pole. The plume rises hundreds of kilometers above a moon only 500 kilometers wide. Most of the escaping material is ice grains and vapor, and most of it falls back as snow. Very little gets away. Roughly 200 kilograms of water leave every second. Cassini did not photograph this from a distance and infer it. The spacecraft was flown directly through the plume again and again, sampling the material with instruments built for dust and gas. 23 targeted passes in all. The deepest plume dive took it to roughly 49 kilometers above the surface. What still bothers people is how steady the jets are. Some brighten and fade as the moon moves along its orbit. Tidal squeezing should open and close the cracks on a schedule, yet the bright peak seems to arrive late. Nobody has pinned down why. Galileo saw Saturn's rings and thought the planet had 2 moons stuck fast to its sides. His best telescope reached about 20 times, enough to show something either side of the disk. It was not enough to show that the thing was flat or that it stood apart. So he wrote of Saturn as a triple body, 3 objects moving together as one. He drew it that way for years. Then in 1612, the rings turned edge onto Earth and went out of his view. He recorded that Saturn had swallowed its own children. The rings had not moved. Earth's viewing angle had, and nobody at the time could have known it. He kept watching and never worked the puzzle out. He died with the shape unexplained, and the answer waited nearly 50 years. It came in the end from better glass and a steadier hand. Others repeated his error with sharper tools, drawing handles, cups and ears onto the planet. A good instrument, read wrongly. Most of the material inside Saturn's magnetic field came from one small moon. Enceladus vents water into space, and the field takes charge of it from there. Sunlight and electron hits break the water apart into oxygen and hydrogen ions. Researchers lump them together and call them water group ions. They spread into a fat ring of plasma wrapped right around the planet. So the planet did not put them there, and neither did the sun. Cassini heard the new ions arrive. Its magnetometer picked up waves at the ion cyclotron frequency. The ringing a fresh ion makes as it starts to circle a field line. That faint ringing traced the plasma back toward its source. Rotation drags the whole ring around, and the mass-laden field lines bulge outward. Thin, hot plasma slips inward in narrow fingers to take their place. Mass keeps arriving, so mass must keep leaving. and yet nobody can balance the books. A leak with no visible drain. Mimas carries a crater so large it should have shattered the moon. Herschel spans about 130 kilometers, and the moon itself is only 400 wide. That is close to a third of the whole ball. Its walls rise kilometers high. The floor sits deep below the rim, and a broad peak rises from the middle. William Herschel found the moon in 1789, and the crater took his name much later. Voyager 1 sent the first clear pictures in 1980. One whole face was almost filled by the hole. The impact came near the energy needed to break Mimas apart. Models say it lived through the blow because it is mostly water ice. Ice soaks up shock in a way rock does not, and the moon may have been softer then. Cracks on the far side, right opposite Herschel, look like shock damage that crossed the inside and met again. But whether Mimas was ever put back together from rubble is still argued. It came close to not existing. Saturn has no surface to land on, and that is not a figure of speech. A probe falling into Saturn would never touch anything. The hydrogen around it just thickens degree by degree, from thin gas to a hot, dense fluid. No boundary lies anywhere along the way. Scientists still need a surface to measure against, so they pick one by agreement. The usual choice is the level where pressure equals 1 bar, close to sea level pressure on Earth. Every quoted radius and every quoted temperature is set against that invented line. Below it, gas turns to liquid with no splash, because above a certain heat, the difference between the two stops existing. Galileo's probe at Jupiter was crushed at about 22 bars of pressure. Saturn would do the same to any lander, only deeper down. So the word landing has no meaning here. The gauges would keep reading until they failed, and then the numbers would simply stop. Nothing waits below. There's nothing to stand on. Saturn's rings grow dark spokes that appear and vanish within hours. Voyager saw them first in 1980, radial smears reaching thousands of kilometers across the B-ring. They turn with the planet's magnetic field rather than with the orbital speed of the ice they cross. That mismatch is the clue. The best explanation is electrostatic. Fine dust grains no bigger than smoke particles pick up charge and lift briefly clear of the ring plane, where they scatter light differently. Only the dust rises, while the larger ice stays put. What charges them is still argued over. Some models point to lightning storms in the atmosphere below, others to bursts of electrons striking the rings from above. Neither gets the timing right. Cassini arrived and found almost no spokes at all, then watched them come back as the rings tilted toward the sun again. Season seems to matter. Spokes favor equinox, when sunlight arrives edge on and the dust can hold its charge for longer. Strong sunlight may strip it away. Nobody has predicted an individual spoke in advance. They still arrive unannounced. Saturn's rings are almost entirely water ice, not dust, not rock. Spectra taken from Cassini and from Earth show absorption bands that match ordinary frozen water. The fraction sits somewhere above 95%, and that purity is the strange part. Saturn sits inside a constant drizzle of dark micrometeoroid dust, so a ring left alone should darken with time. Old roadside snow turns gray, but the main rings have not darkened much. Cassini's dust detector measured the incoming flow directly, and the reddish material it carries is easy to tell from clean ice. The ice still wins. The C ring and the Cassini division are visibly dirtier than the B ring, and the pattern tracks how much ice is there to dilute the dust. Thin regions stain first. Either the rings are young enough that the grime has not piled up, or something recycles the surfaces faster than it arrives. And collisions may bury it. Larger clumps break and reform within hours, which could keep turning fresh ice outward. Nobody has settled which. Titan is the only moon in the solar system with a substantial atmosphere, and it is thicker at the surface than Earth's. Pressure at Titan's surface runs about 1.5 times sea level pressure here. The gas is mostly nitrogen, like ours, with a few percent methane. What makes this strange is Titan's weak gravity, roughly a seventh of Earth's, which should have let a warm atmosphere escape long ago. The cold is what saves it. At around 94 Kelvin, the molecules simply move too slowly to leave. Where the nitrogen originally came from is still argued. Huygens carried a mass spectrometer down through the haze to settle that question. What it found was almost no primordial argon. Nitrogen trapped straight from the early solar nebula would have brought argon with it, so that route is ruled out. The nitrogen isotopes instead point to ammonia ice, broken apart by heat or by impacts, then vented as gas. Ammonia remains the leading idea, but nobody has proved it. The ocean under Enceladus was not assumed from its plume. It took a wobble to prove it. Vapor can in principle come from ice that melts locally or from a warm, slushy pocket. No global sea required. So researchers watched how the moon rocks as it orbits Saturn, a slight back and forth called libration. The signal is tiny. They measured it by tracking hundreds of surface features across 7 years of Cassini images. Each crater was pinned down in 3 dimensions, then followed frame by frame. The libration came out too large for a moon frozen solid all the way through. A rigid shell, locked to a rigid interior, cannot rock that freely. Something has to be sliding. That result, published in 2015, put the wobble near 1/10 of a degree. A frozen moon would have shown a fraction of that. Gravity data agreed, but the wobble is the cleaner argument. It is the reason the ocean is called global rather than local. The whole shell floats. The rings were explained at last by a man who had already found Saturn's largest moon. Christian Huygens saw Titan in 1655 and published his ring idea 2 years later. He argued that one flat solid band circled Saturn without touching it anywhere. His whole proof rested on the vanishings. A thin flat ring seen edge-on would go unseen for a while. It would do that on a set schedule tied to Saturn's slow orbit round the Sun. That is just what watchers kept writing down. He ground his own lenses by hand, and the better glass mattered as much as the idea. He first published the claim as an anagram, the letters jumbled on the page. That was a normal way to stamp a date on a find without giving it away. And it bought time to check the work before a rival could claim the same find. He waited until he was sure, then spelled the sentence out. Solid was wrong. The shape was right. Saturn's northern lights are mostly not lit by the sun. On Earth, a gust of solar particles slams the field and the whole sky glows. Saturn works another way. The planet spins fast and drags the plasma in its field around with it. Plasma further out lags behind, so currents run along the field lines to hurry it along. Those currents fling electrons down into the thin upper air near both poles. Most of the glow leaves in ultraviolet, which human eyes cannot pick up at all. Hubble had to watch in ultraviolet before anyone could map the oval properly. Cassini added a warm infrared glow from charged hydrogen high above the clouds. The oval sits well away from the pole and rings it like a crown. Cassini also found a small separate spot tied to the field line through Enceladus. A moon casting a spotlight, 250,000 kilometers out. How much the solar wind still matters is argued over even now. The two poles disagree. Mima seems to hide a liquid ocean under an unbroken shell. The clue is not plumes and not fresh cracks, because the surface is old and packed with craters. That is what a dead moon should look like. It is the wobble. Cassini watched how Mimas rocks a little as it moves along its orbit. Pictures taken years apart pin the drift of crater centers very closely. The measured rocking came to about 50 arc minutes, and a stiff frozen moon would swing half as far. That extra swing points to an icy shell floating free on water beneath. The only other way to explain it is a strangely long rocky core. So the pull of Saturn keeps flexing the inside, and that flexing makes heat. Later work put the top of the ocean perhaps 20 to 30 kilometers down. It also argued the water may be young, only tens of millions of years old. An ocean too new to have marked the surface yet. A world caught in mid-thaw. Saturn is less dense than water, and the popular version of that fact misleads. Its average density is about 0.69 grams per cubic centimeter, roughly 7/10 that of liquid water. The average is real. The picture it makes is not. A planet bobbing in a giant bathtub is nonsense, because Saturn's own center is packed tighter than rock. The low average comes from a huge volume of light gas wrapped around a small heavy core. It is a claim about bulk, not about floating. Saturn is the only planet here with a mean density below water. The number falls out of two simple things: the mass and the size. Mass comes from watching how moons and passing craft are pulled. Size comes from timing, how long the disk takes to cross a star. Jupiter is about twice as tight in the same units, and Earth is nearly 8 times. So the fact is old, and only the image is wrong. The average hides the middle. There are objects inside Saturn's rings that reveal themselves only by the wake they leave. Cassini found them in the A ring, paired bright and dark streaks, a few thousand kilometers long, shaped like an aircraft propeller. At the center sits a moonlet, perhaps 100 meters across, far too small to image directly. Its gravity is just strong enough to disturb the ring particles flowing past it, opening a gap on either side. The shape is the signature, not the body. The largest were named after early aviators, and one called Blériot was followed through hundreds of separate images across a decade. That record held a surprise. Its orbit drifts back and forth instead of decaying smoothly, which suggests the moonlet is trading momentum with the disk around it. The disk pushes back. Astronomers call the process migration, and it is thought to help set where planets finish up around young stars. Models had to assume it. Here it can be watched directly. Whether these moonlets grew in place or are shards of something bigger is unsettled. Only the wake is plain. The rings are thinner in proportion than a sheet of paper. They stretch some 280,000 kilometers across, edge to edge. Through most of that span, they are perhaps 10 meters thick. Scaled to a sheet of paper, the disk would be wider than a football pitch. The flatness is not decoration, it is bookkeeping. Countless icy particles collide gently, and each collision cancels a little of the up and down motion while leaving the orbital motion untouched. Vertical wandering gets ground away. What remains is a monolayer in places barely one particle deep. Voyager and Cassini both measured the thickness the same way by watching a star wink out as the rings passed in front of it. The dimming timed the edge. Waves complicate the number. Where a moon's pull raises a bending wave, the ring can stand a kilometer tall, so the 10-meter figure describes the quiet parts. Most of it is quiet. Nobody has resolved a single particle. Their sizes come from radio signals sent through the disk. Besides Earth, only Titan has standing liquid on its surface. The seas are not water, they are methane and ethane, pooled in the polar lowlands at temperatures where water ice behaves like granite. The largest Kraken mare is bigger than the Caspian Sea. Cassini's radar reached the floor of the smaller sea, Ligeia Mare, and timed the echo at about 170 meters down. That echo carried more than depth. Liquid clear enough to bounce a beam off the bottom has to be mostly methane. Too little is dissolved in it to absorb the signal. In the middle of Kraken, the echo never came back at all, so the floor there lies deeper than 300 meters. What no one can fully explain is the imbalance. Nearly all the lake area sits in the north, while the south holds only small ponds and dry basins. Slow orbital cycles may move the liquid from pole to pole across tens of thousands of years. The mechanism remains a proposal. The seas keep their secret. The ice shell over the South Pole may be only a few kilometers thick. Elsewhere, it is tens of kilometers. That difference comes out of gravity data and topography measured together. Cassini's radio signal was tracked as the moon's mass tugged on the spacecraft. A pull of less than a millimeter per second shows up in the frequency of the carrier wave. That is enough. The tug reveals how mass is distributed inside. Combine it with the shape of the surface, and the thickness of the lid falls out. The average lands near 20 kilometers. Under the active pole, it may be 5 or less, and the numbers have moved more than once as the models improved. Early estimates ran far thicker before the libration forced a thinner shell. A thin polar lid is convenient because it explains why the cracks reach water there and nowhere else. Convenient is not proven. Thinning is easier to observe than to explain. Nothing says the lid must stay thin. A proof done on paper in 1859 showed the rings could not be solid. James Clerk Maxwell showed that a stiff ring of that span would tear itself apart. Saturn's pull is stronger at the inner edge of a ring than at the outer one. That gap in pull would break any rigid plate, however strong the stuff it was made from. But a ring of pure fluid would fare no better. It would gather into clumps, and the clumps into lumps. Only one arrangement was left standing at the end. The rings had to be a vast crowd of small bodies, each on its own path. Maxwell won a prize for the work, and he never saw Saturn close up. Proof came later from light itself. The inner edge was clocked moving faster than the outer edge. That is what free orbits demand, and what a spinning plate forbids. James Keeler made that measure in 1895, 36 years after the maths, pen and paper first. Saturn keeps a belt of radiation that seems to be made by its own rings. The trapped protons each carry tens of millions of electron volts of energy. That is far too much to have been simply swept up from the plasma nearby. The favored answer has a clumsy name and a very simple shape. A cosmic ray from deep space smacks into ring ice or the upper air. The impact knocks loose free neutrons. A neutron carries no charge, so the magnetic field cannot steer it. It drifts straight across the field lines until it falls apart on its own. What it leaves behind is a proton and an electron, and now they are trapped. So the rings work as a target that quietly makes fresh radiation. The belt hardly flinches when the solar wind gusts, which sets it apart from Earth's. Cassini's particle counter also found a narrow belt tucked just inside the innermost faint ring. Nobody had expected anything to survive in that gap. No spacecraft had been there before. One side of Iapetus is about as dark as asphalt, and the other is nearly as bright as fresh snow. The gap in reflectance is roughly a factor of 10. It lines up almost perfectly with the way the moon travels, dark side forward. The mechanism turned out to be a runaway. Dust drifting in from Saturn's distant outer moons coats the leading face. That face then warms a little more in sunlight. Its ice turns to vapor and moves to the colder bright side, leaving the dark stuff behind. Each step makes the next step stronger. The long day helps. Iapetus turns once in about 79 days, so the dark ground has time to heat past the point where ice starts to escape. And the dark layer itself is thought to be thin, a coating rather than a crust. Cassini flew close in 2007 and mapped the border, which is patchy and sharp at small scales. What is still argued is where exactly the dust starts. The moon paints itself. A hexagon sits over Saturn's north pole, 6-sided and thousands of kilometers across. Each side is wider than Earth. Voyager saw it in 1981, and Cassini watched it for over 10 years. In all that time, it never wandered off or fell apart. The shape looks like a jet stream locked into a standing wave, a river of wind that closes on itself with 6 bends instead of a circle. Lab work backs this up. Spin a tank of fluid at differing rates and jets with corners appear. The number of sides depends on how sharp the shear is between the fast band and the slow one. The wind along that boundary runs at hundreds of kilometers per hour. The corners barely move while the clouds inside race past them. What stays unresolved is how deep into the planet the pattern reaches. And nobody can say why the South Pole has nothing like it. Both poles spin, and only one has edges, weather holding its corners. The rings are not a smooth sheet, but a shifting mesh of trailing threads. Self-gravity pulls ring particles into elongated clumps tens of meters wide. Saturn's shear tears those clumps apart at once, so they form and dissolve without pause, canted at a fixed angle to the orbital direction. These are called self-gravity wakes. No camera has ever resolved one. They were inferred instead by two separate routes. The rings look brighter from some viewing angles than from others, an asymmetry noticed from Earth long before any spacecraft flew. Then Cassini watched stars hit behind the rings, and the starlight dimmed by different amounts depending on the direction the light cut across the grain. The pattern behaves like a Venetian blind. Modeling puts the tilt near 20 degrees. Individual wakes may last only a few hours before reforming. They also hide mass. Because the ice bundles into threads, light leaks through the gaps between them, and the rings read as emptier than they are, a denser sheet than it looks. Twice in every Saturn year, the rings vanish from Earth entirely. Saturn's axis leans by roughly 27 degrees. The planet needs about 29.5 Earth years to circle the Sun, so twice per orbit our line of sight crosses the ring plane exactly. Then we see them edge on. 10 meters of ice, viewed across more than 1 billion kilometers, reflects almost nothing. Even good telescopes lose them for days. The vanishing is gradual, not sudden. Over weeks, the rings thin to a bright line, then to a thread, then to nothing. But the crossings are useful now. With the bright rings out of the way, faint moons close to the planet are far easier to catch. Glare is the usual enemy. Herschel found Mimas and Enceladus in 1789, with the rings turned nearly edge-on. The timing was no accident. The last crossing fell in 2025. Another comes about 14 years later. For 25 years, nobody could see Titan's surface at all. Voyager flew close in 1980 and returned a featureless orange ball because the haze scatters visible light completely. The fix was to look in wavelengths the haze is thin at. Hubble found the first blotches in 1994. They were maps of light and dark, nothing more. Cassini carried a radar that punched straight through, plus infrared filters tuned to narrow gaps in the methane absorption bands. Those gaps are very narrow. Through them, the ground appears as if down a series of keyholes, one color at a time. The views have to be stitched into a map. The first radar swath in 2004 showed river channels and dunes, where many had expected a global ocean. 13 years of flybys still left under half the moon imaged at the radar's sharpest setting, because each pass draws one thin strip, and some of the highest terrain is only sketched. Whole regions have never been seen twice. Cassini detected molecular hydrogen in the plume, and that single measurement changed the conversation. Hydrogen matters because on Earth, whole ecosystems at hydrothermal vents run on it. Microbes combine hydrogen with carbon dioxide and get energy out. Free hydrogen escaping Enceladus means the ocean is not in chemical equilibrium with its rocky floor. Water is attacking rock. The reaction releases hydrogen faster than anything down there is consuming it. The instrument was a mass spectrometer flown low through the plume in 2015. It read the gas directly rather than inferring it from brightness. Hydrogen came in at about 1% of the vapor, and careful teams spent a long time ruling out the obvious alternative. Water molecules slam into the walls of a spectrometer at flyby speed. Metal surfaces can crack them and make hydrogen inside the instrument itself. Laboratory tests and titanium walls close that door. The energy is genuinely available. Nothing shows it is being used. The first craft sent to Saturn went partly to find out whether the next ones would live. Pioneer 11 arrived in 1979 and crossed the ring plane on purpose. A later mission, far more costly, would need to use that same narrow gap. Nobody on the ground knew how much dust and rubble sat outside the bright rings. A grain the size of sand can wreck a craft at that speed. So Pioneer's job was partly to be the test object. It went first so that Voyager could go safely. It lived through the crossing and found a faint outer ring nobody had seen. It showed that one point in the plane was clear enough to risk. Its camera was crude next to anything that came after. The thing worked more like a light meter that swept the sky in narrow strips. The planet built up line by line as the craft spun on its axis. The pictures were soft and few. The scouting mattered more. Saturn's rings absorbed the radiation belts rather than holding the belts inside them. The belts stop sharply at the outer edge of the main bright ring. Any charged particle drifting inward has to cross the ring plane sooner or later. It meets a lump of ice, and then it is simply gone. The moons do the same work, cutting gaps in the trapped particles wherever they travel around. So Saturn is a far gentler place for a spacecraft than Jupiter. Jupiter's belts can wreck a spacecraft's electronics within a few weeks. Cassini lasted 13 years, partly because the rings kept quietly cleaning house. The oddity came last. For its final orbits, Cassini dived through the narrow gap between the rings and the cloud tops. Engineers had turned the big dish antenna forward to work as a shield. The dust detector barely registered a thing, and the shield was hardly needed at all. Models had put far more material in there than the instruments could hear. Sometimes, the surprise is nothing. A ridge of mountains runs almost exactly around the equator of Iapetus. It stands roughly 13 kilometers high. That is taller against its own world than anything on Earth. Cassini found it on the last day of 2004. The visible stretch runs well over 1,000 kilometers. It follows the equator so closely that chance is hard to believe. Nobody has a settled answer. One idea is that Iapetus once spun far faster and froze into a flattened shape, leaving a seam where the crust buckled. Its present bulge does fit a much shorter day than the 79 it keeps now. Another idea is that a ring of rubble, perhaps from a smashed companion moon, rained down along the line of the equator. It would have piled up where it fell. The ridge is heavily cratered, so whatever built it happened very early. But no probe has flown close enough to see how it is put together. A wall left by something finished. The hexagon changed color while Cassini was watching. Early in the mission, the inside of the polar region looked blue. By the time northern spring had arrived, it had turned toward gold. The best account anyone has is chemical. Through the long polar winter, there is no sunlight, so the haze grains that cast a yellow tint are simply not made. So the air clears, and the deeper blue shows through from below. When the sun comes back, ultraviolet light restarts the chemistry and the haze rebuilds. That gives the pole a set of seasonal colors, each season running about 7 Earth years. The whole cycle takes near 30. Cassini arrived in 2004 and left in 2017, so it caught barely half of one turn of that wheel. The same color clock should run at the South Pole, offset by half a year. Nobody has watched it there, and nobody called the shift before it was seen. It changed while being photographed. One narrow ring is held in place by 2 small moons that squeeze it from either side. Pandora orbits just outside Saturn's F ring and Prometheus just inside, and their combined gravity was long thought to confine the ring's material to a band only a few hundred kilometers wide. That tidy picture has since frayed. Detailed tracking showed the 2 moons cannot account for the confinement on their own, and both wander in their orbits in ways that are hard to model. They are also locked together. A resonance between them makes both orbits chaotic, and every 6 years or so their positions jump. One gains, the other loses. Neither moon is solid rock. Both are elongated, low-density piles of ice, easily reshaped. Prometheus also reaches into the ring at closest approach, drawing out dark channels of stolen material. And those channels return on a beat of a little over 2 months. The shepherd idea survives, incomplete. Weighing the rings required flying between them. For 3 centuries, the mass could only be guessed. A ring's brightness reports surface area rather than bulk, so a disk of small grains can look as solid as a disk of boulders. Light tells you the wrong thing. Cassini's last orbits in 2017 threaded the 2,000-kilometer lane between the cloud tops and the inner edge, close enough to feel both poles. Radio signals sent to Earth recorded the spacecraft's speed to a fraction of a millimeter per second. The ring's share was separable. The answer came out near 4/10 of the mass of Mimas. That is a small moon spread across a disk wider than the Earth-Moon distance, and gathered into one body, it would be unremarkable. A ball roughly 300 kilometers across. The same measurement fixed how much of Saturn's gravity comes from deep winds, which had muddied earlier attempts. 2 unknowns, 1 set of orbits. 22 passes, 1 number. The methane in Titan's air should not exist, because sunlight destroys it in tens of millions of years. Ultraviolet light splits methane apart in the upper atmosphere, and the hydrogen escapes to space for good, so the loss runs one way. Titan is over 4 billion years old. Something must be resupplying the gas, or the atmosphere we see is a temporary phase we happen to be watching. There is a second half to the problem. All that broken methane should have left ethane behind, enough for a global ocean hundreds of meters deep. The seas that exist hold nowhere near it. So the products go missing as fast as the source does. Nothing in the budget balances. Cryovolcanism was the favored answer for years. Then the candidate volcanic features on radar turned out to be ambiguous. A slow leak from a deep reservoir of methane clathrate is now more popular, with the missing ethane soaking down into the crust, but no source has been found. Silica grains in Saturn's rings pointed to hot water on a seafloor nobody has seen. Cassini's dust analyzer found tiny particles of silica in the stream of material coming from Enceladus. They were only nanometers across. Silica dissolves in water under fairly specific conditions. Grains that small form when hot mineral-rich water cools quickly. Laboratory work narrowed the conditions to temperatures above about 90 degrees Celsius. It also demanded low salinity and a slightly alkaline sea. That is not a lukewarm ocean. Water is circulating through hot rock at the bottom. It must rise fast, in months rather than centuries, or the grains would grow. Then the plume launched them, and Saturn's magnetic field sorted them by charge. The particles reached Cassini as a thin stream far from the moon. The chain of reasoning is long, and every link has been argued over, but the grains were really there, and they had to come from somewhere. Something is cooking down there. Voyager found ring features that no theory of the day could explain, and some are argued over still. The 2 flybys came in 1980 and 1981, months apart. They showed that the rings were not a few broad bands at all. There were thousands of thin ringlets instead, nested one inside the next like grooves. Some looked braided, some were kinked, and some held gaps held open by tiny moons. But others carried dark streaks that ran outward like spokes on a wheel. The spokes turned with a magnetic field, not with the particles below them. That was the odd part. Nothing solid moves that way, so the spokes cannot be solid. The best reading is fine dust lifted just above the ring plane by electric charge. What sets the dust off, and why in bursts, is still open. Cassini later found that the spokes come and go with Saturn's seasons. They faded for years, then came back as the light changed. The lifting is not settled. A single bolt of lightning on Saturn can be 10,000 times stronger than one here. Cassini could not see most of the flashes through the haze, so it listened instead. Its radio receiver picked up rough bursts of crackle, much like static on an old radio set. Observers named them Saturn electrostatic discharges. The rate and the strength of the bursts let a storm be tracked while it stayed invisible. Amateur astronomers on Earth then found the visible storm clouds that matched the crackle. Hobbyists and $1 billion spacecraft were working the same target at once. In time, the cameras did catch flashes on the night side. They glowed from far down inside the water cloud layers. What no one can settle is where all that energy comes from. Saturn gets only about 1% of the sunlight that Earth gets, and yet it drives storms more violent than anything on this planet. The heat is coming from below. Perperion has no steady spin, and there's no way to say how it will face. Most moons settle into a locked spin, or at least a steady one. Hyperion is badly out of round. Its longest axis runs about 360 kilometers, and it is far narrower the other way. It also sits in an orbit tugged by nearby Titan, which it circles in step, 3 of its years to 4 of Titan's. So the torques on it never repeat cleanly. The result is true chaos, the textbook case in the solar system. Theory called it in the early 1980s before anyone had measured it. Voyager 2 and later Cassini bore it out by watching its brightness rise and fall in ways no fixed spin explains. Small changes in its state now grow into a wholly different tilt later. Forecasts fail within a few months. The tumbling also means the whole surface bakes and freezes in turn. Nobody knows next year's view. Saturn's equatorial winds beat any wind on Earth by a wide margin. Earth's strongest jets top out near 400 kilometers per hour. How much faster Saturn runs is disputed. Voyager put the fastest jet near 1,800 kilometers per hour, and Cassini measured closer to 1,300. The trouble is the reference frame. Measuring wind means knowing what the wind is moving against, and on a planet with no ground, that frame has to be worked out rather than seen. Cloud tracking gives one answer, and it drifts between epochs. But the winds themselves may not have changed at all. The two craft may have watched clouds at different heights. Saturn's radio beat drifted by minutes between visits, so it failed as a clock. There is a deeper puzzle under the speed. Saturn gets about 1% of the sunlight Earth does, so very little energy arrives to drive weather that violent. Some of the power has to come from inside. The engine is not the sun. The F-ring keeps producing bright knots and strands, then losing them. Images taken months apart show the same region unrecognizable. Braided filaments, kinks, and clumps appear where the ring was smooth before. The favored explanation is collisions. A population of small unseen bodies embedded in or near the ring is thought to be crashing into the dense core and throwing out plumes of ice dust. Each plume spreads along the orbit, then fades. Cassini cataloged hundreds of these small streaks and called them mini-jets. Their relative speeds are only a couple of meters per second, slower than walking pace, which is why the intruder survives the hit and can come back to do it again. Nothing shatters. Some of those bodies may be temporary, assembling and being destroyed over and over. The bright core itself is narrow, a strand tens of kilometers wide inside a much broader haze of dust. It is the most active structure known in the solar system at this scale. Nothing about its appearance can be predicted a year ahead. The ring's low mass is the strongest argument that they are young. The logic is a race between two clocks. Interplanetary dust falls onto the rings at a rate that can be measured, and the dark material stays. Contamination behaves like a stain. A light ring holds less ice to dilute what lands, so a given amount of grime shows up sooner. Mass sets the dilution. Cassini's dust analyzer caught the grains arriving and sorted them by composition. Run those numbers on 4/10 of amoebas and the rings look young. The instrument puts them between 100 million and 400 million years old. That is younger than many dinosaurs. But the weak link is the dust rate itself. It is measured now at one moment in the outer solar system, and the flux may not have held steady. Early bombardment was heavier. A clock that ran fast once would make an old ring look new. Critics press exactly there. It rains on Titan, but a raindrop takes minutes to reach the ground. Methane droplets there grow far larger than water drops on Earth, up to about a centimeter across. They fall through thick, cold air under weak gravity. Terminal speed is a slow walk. Smaller drops never arrive because the lowest few kilometers are dry enough to evaporate them on the way down. Storms are rare and enormous. Clouds gather for years, then let go at once. Cassini watched one dark patch appear across an area the size of a small country after a cloudburst. Then it slowly brightened as the liquid drained or soaked away. That brightening is the only direct measure anyone has of how fast Titan's ground sheds a storm. What the total rainfall adds up to over a Titan year is not settled. Models put the global average near a centimeter of methane, spread very unevenly. So most of the surface may go centuries between soakings. Drizzle, then decades of nothing. The tiger stripes are 4 long parallel fractures, and their spacing is suspiciously regular. Each runs roughly 130 kilometers. They sit about 35 kilometers apart. Nothing about a randomly cracking ice shell should produce even spacing like that. The stripes are also warm, glowing along their whole length in Cassini's infrared mapper. Heat leaks from the cracks themselves. One explanation, published in 2020, starts with a single fracture. Water rose in it and froze on the flanks, which loaded the shell with new ice. The load bent the surface. That bending made the next crack form at a predictable distance, then the next. So they would be siblings rather than coincidences. The model also predicts they are all about the same age. It needs a shell thin enough to crack right through, which the South Pole may have. The North Pole does not. Why one pole cracked and the other did not remains open? Both should feel the same tides. Cassini took nearly 7 years to reach Saturn, and it got there by flying inward first. It left Earth in 1997 weighing over 5 tons with all its fuel aboard. No rocket then flying could throw that much mass straight out to Saturn, so the craft was sent the wrong way on purpose, in toward the Sun. It swung past Venus twice, then Earth, then Jupiter. Each pass took a small share of that planet's own motion round the Sun. The planet slowed by an amount far too tiny to measure. The craft gained years of travel that it could never have bought with fuel. The Earth pass brought a nuclear-powered craft back past its home world at close range. It ran on heat from plutonium, since sunlight is far too thin that far out. Crowds gathered to protest, and lawyers filed in court to stop the launch. They published the odds and flew. 4 planet swings stood in for a rocket stage that did not yet exist. Physics, not preference. One storm in 2010 grew until it wrapped right around the planet and bit its own tail. It began as a small bright spot in the northern half in December of that year. Storms of this size show up about once in a Saturn year. Saturn's winds run at hundreds of meters a second, and they change with latitude. So the storm smeared eastward into a long ribbon of pale cloud. The head stayed the engine of it, churning bright ammonia ice up from below. After roughly 200 days, the head caught the drifting tail of its own wake. The meeting killed it. By late 2011, the visible storm had gone. The air above it stayed disturbed for years afterwards. Cassini's infrared instrument watched a huge warm patch linger high in the stratosphere. At its peak, the storm covered roughly 8 times the whole surface area of Earth. A storm that strangled itself. Hyperion looks like a sponge, and the holes come from it being mostly empty. Cassini passed within about 500 kilometers of it in 2005. That pass is where the numbers come from. Its density is around half that of water ice, just over half a gram for each cubic centimeter. That means well over a third of its volume is void. It is a loose rubble pile rather than a solid body. It would float in water. When something strikes a surface that's porous, material squashes inward instead of being thrown out. So craters punch deep pits with steep walls, and very little debris lands nearby to soften the edges. One of them runs about 120 kilometers wide. Dark material collects on the pit floors and warms in the sun, which drives off ice and digs them deeper. The result is a land of clean, sharp holes unlike anywhere else photographed. A world built mostly of gaps. Saturn gives out far more heat than it takes in from the sun, and the excess has never been fully explained. The measured heat leaving is about 1.8 times the sunlight arriving. Voyager's infrared instrument made the first firm version of that ratio. Slow shrinking under gravity works for Jupiter, but it does not cover all of Saturn's output. Age is part of the trouble. Some say a body of this mass should have cooled far more by now. Saturn is smaller than Jupiter, so it should have run down faster and be cooler. So something else is letting go of energy in the deep interior. The leading candidate is helium pulling out of the hydrogen and sinking, since falling matter turns gravity into heat. Other ideas involve layered convection, where heat is trapped and freed in steps rather than carried smoothly up. Both pictures fit the total, and neither is proven. The heat budget still does not close. Warmer than it should be. Close to a planet, a moon cannot hold itself together. Saturn pulls harder on the near side of a body than on the far side, and that difference stretches it. A moon's own gravity fights back, trying to pull the whole thing into a ball. Inside a certain distance from Saturn, the stretching wins. That distance was worked out in the 1800s by a French astronomer. Loose material inside it can never gather into a moon, so it stays spread out as a disk. Outside that line, the same material clumps and stays clumped. Saturn's main rings sit almost entirely inside the boundary, and the large moons sit outside it. That is no coincidence. But the line is not a wall. Where it falls depends on how dense a body is, and on how firmly it holds itself together. Solid rock can survive closer in than a loose pile of ice. Small bodies do survive inside the rings, held together by more than their own weight. The boundary is a smudge. 100-million-year-old ring implies something broke apart while dinosaurs were alive. This is the part that unsettles people. If the rings really are that young, Saturn spent most of its 4.5 billion year history bare. Then something crossed the line. Inside the Roche limit, tides pull harder than a moon's own gravity can hold. An icy body a few hundred kilometers across came apart there. The debris flattened and spread into a disk within decades. The trouble is the parent. No convincing candidate has been identified, and the chance of such a disruption happening recently rather than early is poor. Late accidents are rare. One family of models blames Titan. As Titan migrated outward, it destabilized an older moon, which fell inward and was shredded. That moon has a name and no evidence, only a gap in the accounting. Saturn's tilt fits that story too. And others argue the rings are ancient, but constantly cleaned. The debate is live. Huygens landed in mud, and the sound of the impact told scientists so. The probe hit the surface in January 2005 with a deceleration trace that looked like a small stone pushed into wet sand. There was no bounce in it. The fall through the atmosphere took 2.5 hours. A sensor on the underside felt a thin crust give way, then softer material below. The ground was firm at the skin and yielding beneath. Then its instruments detected a puff of methane rising from soil warmed by the probe's own heat. The surface was damp, like a beach above the waterline. It kept transmitting for about 70 minutes on the ground until Cassini sank below the horizon. Earth's radio dishes heard it longer. One of its 2 data channels was never switched on aboard the orbiter, a single command left out of the sequence. About half the pictures went with it, but the rest survived by luck. Saturn's E-ring is not debris from ancient collisions. It is being manufactured continuously by one small moon. The E-ring is a broad, faint band of ice grains, and Enceladus orbits inside it. The moon sits at the core. Grains launched by the plume that escape its weak gravity go into orbit around Saturn. Escape there takes only a couple of 100 meters per second. They spread into a torus far wider than the bright rings. The composition matches, the orbit matches, and the ring's brightest region sits right at Enceladus. This also means the ring is young in a mechanical sense. Individual grains do not last. Plasma sandblasts them, and the larger moons and the magnetic fields sweep them up. Decades to centuries is the usual estimate for a grain's life. The ring also feeds oxygen into the space around Saturn once the ice breaks apart. So the tap has to stay open. Switch the plume off and the E-ring fades. The probe that landed on Titan had to live with a choice made a decade earlier. Nobody then knew what the surface under the haze would turn out to be, so Huygens was built to work on solid ground or on liquid, either one. Some models had Titan covered in a deep sea of ethane, others in rock and sand. Earth could not settle it. The builders hedged and made the probe able to float if it had to. It carried a sensor to measure the splash and a lamp and heater for a wet landing. In 2005, it came down on damp ground strewn with rounded pebbles. The stones were smooth, which means something had rolled them along. One of the two radio links carrying data home went dead. The receiver aboard Cassini was never told to switch that link on. The command had been left out of the flight software on the ground. Roughly half the pictures went with it. A ground error, found too late. Saturn's magnetic field seems to breathe in and out about every 11 hours. The pulse does not come from the solid body of the planet itself. Cassini found nearly everything out there beating it close to the planet's spin period. Plasma density, field strength, fast particles, and radio noise all rose and fell in step. Something lopsided is going round. Researchers call it the cam, as in a cam pushing on a follower. The trouble is that a truly even field ought to give no beat at all. Voyager timed the radio beat first, and by Cassini's arrival, it had slipped by minutes. A planet's core does not change its spin in 20 years. So the clock has to sit somewhere higher up. Current thinking puts a slowly turning vortex or wind pattern in the upper air, twisting the field lines and sending the beat outward. The north and the south keep slightly different time. A clock face with no hands. Two of Saturn's small moons are shaped like ravioli, and the ring they live in made them that way. Pan and Atlas both carry a smooth flange of stuff around the equator. It sits on a rounder core, so the profile looks like a disk with a rim. Each is about 30 kilometers across. Pan clears a gap in the outer ring, and Atlas rides just beyond the edge. Cassini took the sharp pictures in 2017, on close passes late in the mission. Before that, they were little more than dots. The answer is growth inside the rings. Material orbiting at almost the same speed drifts onto the moon gently, and it arrives mostly at the equator, because that is the plane it comes from. So it builds a skirt rather than a shell. Models of slow mergers give the same shape. Neither would look like this outside the rings. What is less clear is how old these moons are. Ring stuff, stacked into moons. Deep inside Saturn, helium may be falling as rain through liquid hydrogen. Thousands of kilometers down, the pressure is millions of times what we feel at sea level. At those conditions, helium and hydrogen stop mixing, the way oil parts from water. The helium gathers into droplets, and being denser, they sink toward the center. This is not a metaphor. It is a real change of phase, worked out from lab squeezing and from theory. The energy freed as the droplets fall is a main account of Saturn's extra heat. The evidence is indirect but pointed, since Saturn's upper air is measurably short of helium. It holds less than the mix the Sun was born from, so the missing helium went somewhere. Down, most likely. Jupiter shows a smaller shortfall, and that fits, because Jupiter runs hotter inside, and hotter fluid keeps the two gases stirred. But nobody has seen a droplet, and the layer is far past any reach. Falling for billions of years, the outer edge of the brightest ring is not a circle, but a slowly turning oval. The B ring's outer boundary is held by a resonance with Mimas, and the edge is drawn out into an ellipse whose long axis rotates in step with the moon. Superimposed on that are further distortions that no moon accounts for. Cassini found additional lobed patterns at the same edge, and their shapes changed over the mission, suggesting the ring edge oscillates on its own. Something inside the ring is setting those. The region is also the densest part of the rings and the hardest to measure because light struggles through. Where a ring is opaque, an occultation stops reporting. The mass hidden behind the block has to be reasoned out rather than seen. Estimates of how much sits there have moved substantially. The edge is sharp too. The transition from full ring to empty happens over a few tens of kilometers at most, sharper than any model comfortably explains. The gap Cassini is named for is not empty. No moon orbits inside it. The Cassini division separates the A and B rings and spans roughly 4,700 kilometers. Dark, but not vacant. It holds ringlets and thin sheets of material. Its inner edge sits where particles circle Saturn almost exactly twice for every one orbit of Mimas. The timing is the trap. Mimas tugs the same particles at the same point in every second lap. Small nudges add rather than cancel, and the orbits stretch until the region drains. Radial measurements show the drain zone is not clean, and the material inside it moves on stretched paths. Something keeps stirring it. Giovanni Cassini spotted the lane in 1675. He could not have guessed the cause. Why the division is so much wider than the resonance alone predicts is still argued. A moon need not be present to sweep a gap. It only needs to keep good time. The rocks in the only surface photograph ever taken on Titan are water ice, and they are rounded like river cobbles. Huygens looked out across a flat plain scattered with lumps a few centimeters wide, some clearly smoothed, some sitting in shallow scoured hollows. That is the signature of material tumbled by flowing liquid. The plain ran flat to the horizon. The channels visible in the descent images fed into that plain. So the site was a dry stream bed, or something very like one. Stones that size are not carried gently, which argues for short violent floods rather than any steady river. The probe switched on a small lamp for the last stretch of the fall. It lit the ground and read its true color before the batteries died. What nobody expected was how dark the pebbles looked, suggesting a coating of organic material rather than clean, bright ice. The camera saw only a few meters of ground. That coating has never been sampled. Dragonfly may finally taste it. The heat coming out of Enceladus is roughly 10 times more than tidal heating easily explains. The gap is embarrassing. Estimates for the south polar terrain run from about 6 gigawatts to 16. Infrared mapping gave those numbers by measuring how strongly the stripes glow. Tidal flexing is the only plausible source. The moon is far too small to still be warm from its formation, but the standard calculation for this orbit at this eccentricity gives a steady figure far below what Cassini measured. Something must be missing. Perhaps the heat is made in a porous rocky core rather than in the ice. Water forced through fractured rock rubs and warms, which ice does far less well. Perhaps the output is episodic, and the moon is in a warm phase after a cool one. Perhaps the orbit was recently rounder. The resonance with Dione is what keeps the eccentricity alive, and that lock may have tightened and loosened. The energy budget still does not balance. Cassini was destroyed on purpose to guard 2 moons it had just made interesting. It had found liquid water spraying out through cracks at the south pole of Enceladus. It had found a chemistry there that might feed life of some kind. It was also running low on the fuel it steered with. A dead craft cannot be steered. Left alone, its orbit would drift for centuries and sooner or later hit a moon. So in September 2017, the team flew it into Saturn itself. It burned in the upper air, sending fresh data until the signal broke. Whatever microbes from Earth had lived through 20 years in space burned with it. The rules that forced this choice were written long before the mission arrived. Nobody then suspected that Enceladus held an ocean under its ice. The craft had no way to be cleaned once it left the ground. Its last act was to taste the air it died in. It ended to protect its find. Saturn's field throws plasma away in great blobs, and the throwing has actually been watched. Material shed by the inner moons keeps loading the field lines with fresh mass. Rotation flings that mass outward until the lines stretch into a long tail running downwind. In time, the stretched lines pinch off and let go. A bubble of plasma sails away downstream, and the rest snaps back toward the planet. Researchers call the bubbles plasmoids. Cassini caught the magnetic signature of the snap, which can play out in a few minutes. The aurora brightened at the same time, which tied the far-off snap to a visible glow. The events seem to repeat, and many arrive with the 11-hour beat. On Earth, this drives a substorm. But Earth's fuel is the solar wind, and Saturn's is a moon. The accounting still does not balance, because the blobs carry off only a fraction of what arrives. The rest leaves some quieter way. Phoebe orbits Saturn backwards, and it did not form there. It runs the wrong way, against the spin of the planet, and against every large inner moon. It also sits far out, roughly 13 million kilometers. One trip round takes about a year and a half. Bodies that grow with the planet take up its way of turning, so a backwards orbit means capture. Phoebe was found in 1899, the first moon anywhere caught on a glass plate rather than by eye. Cassini flew past in 2004, before it had even reached Saturn. The pictures showed a battered dark ball roughly 200 kilometers wide. Bright water ice sits bare in the crater walls under a dark coat. Its density is high for this system, which hints at a body that once split into layers. The likely story is a Kuiper belt object snared long ago. How a passing body sheds enough speed to be caught at all is still a hard problem. A visitor that never left. Saturn's core may not be a solid ball at all, but a fuzzy region tens of thousands of kilometers wide. The old picture was tidy, a rock and ice center with a sharp edge wrapped in hydrogen. Cassini's fine gravity readings point somewhere else, and so do waves found in the rings themselves. Both suggest heavy elements smeared into the hydrogen with no clean edge. That blurred region may reach about 60% of the way out to the surface. The figure comes from ring seismology, published in 2021. The heavy element load runs to many Earth masses, and it matters for how Saturn was built. A diffuse core is hard to make by growing a solid seed and then piling gas on top. Growing that way should leave a line you could point at. So the reading may mark a violent early impact, or the heavy stuff may never have settled. Nobody can sample it. The middle is blurry. Some ring features are the fading scar of an impact decades old. A tilted corrugation runs through the D ring and the inner C ring, a gentle vertical ripple whose wavelength shortens as the years pass. That shortening is a clock. Wound backwards, it points to a moment around 1983 when a cloud of debris is thought to have swept through the ring plane. A broad annulus was knocked askew. The tilt then wound itself into a tightening spiral. Voyager had flown past a few years earlier, and its images show no such ripple, which brackets the event neatly. The ring was flat, then it was not. A similar corrugation was found in Jupiter's ring and traced to the Shoemaker-Levy 9 impact. So the method has a control case. Nobody was watching Saturn closely in 1983. No comet was ever identified. The ring recorded it anyway. One gap really does have a moon inside it. Pan holds the edges open with waves. The Encke gap in the outer A-ring is about 325 kilometers wide. Pan orbits along its center. The moon is a lumpy thing, roughly 28 kilometers across. Ring material has settled on its equator, giving it the outline of a ravioli. The ridge around its middle is a few kilometers high. Pan's gravity gives every passing particle a small kick. Particles just inside orbit faster than the moon, and those outside orbit slower. So the kicks pile into scalloped edges that trail behind in a regular wave. Cassini photographed the scallops directly. The wavelength depends on distance from the moon. which turns the pattern into a ruler. Mark Showalter predicted the moon from those scallops and found it in Voyager frames in 1990. The waves weigh their maker. Faint strands of dust still run down the middle of the gap. Remove pan and it closes. Titan's dunes hold more carbon than all of Earth's oil, coal, and gas combined, and the sand is not sand. Hundreds of times Earth's known coal reserves. Radar found vast fields of parallel ridges around the equator, hundreds of kilometers long, 100 meters tall, spaced a kilometer or two apart. The grains are a fraction of a millimeter across and very dark. No bright ice shows through them anywhere. They are thought to be solid organic molecules made in the haze and settled out over ages. Something then clumped them into grains heavy enough to blow. How soft organics survive that tumbling instead of grinding to dust is unresolved. The dunes also pointed the wrong way. Every ridge records net transport towards the east, while the models had the surface winds blowing west. The fix on offer is rare violent gusts near equinox, which reverse the flow for a few days and do all the shifting. Nobody has watched one happen. That contradiction is still open. The plume contains organic molecules large enough to be fragments of something bigger. Cassini's dust instrument found grains carrying complex organics. Their masses ran well above the simple methane and carbon dioxide also present. Some fragments were pieces of aromatic structures, torn apart on impact with the detector. They came in above 200 atomic mass units. The parent molecules were bigger still. Impact speed matters here, because a grain striking at kilometers per second shatters what it carries. The pieces are what got measured. The organics ride mostly in the grains, not in the gas around them. That points to a film floating on the ocean's surface, scooped up and launched by rising bubbles. Later reanalysis of the same archived data reported nitrogen-bearing and oxygen-bearing compounds. Some take part on Earth in the chemistry leading to amino acids. None of that requires life. Hot water and rock make organics without any help. The point is narrower and still important. The ingredients are there. Cassini's last orbits found that Saturn's deep inside does not turn as one body. Flying close in let the team weigh the planet layer by layer. Small tugs on the moving craft were used to map the gravity field in detail. The outer layers turn at different rates rather than as a rigid whole. That flow runs down to something like 9,000 kilometers below the cloud tops. Below that depth, the planet seems to turn as one piece. This matters more than it sounds. Saturn's true day length had never been pinned down. There is no solid ground to time and no marks to watch go by. On most planets, the magnetic field serves as the clock instead of the ground. Saturn's field sits almost square with the spin axis, so it gives no wobble. So the fallback clock does not tick. And the deeper trouble is not the measuring. If each layer turns at its own rate, no one number is the day. None of them is wrong. The radial pulse from Saturn comes in 2 beats at once, one from each half of the planet. The north keeps its own period, and the south keeps another. They differ by only a few minutes, close enough that early listeners heard a single blurred signal. Cassini listened for years and pulled the two apart, sorting the waves by which pole had sent them. Each half was clocking a slightly different length of day, both near 10 hours and 3/4, and the two were minutes apart. But neither number is fixed. Both drift slowly, month by month, and they close on each other as the seasons turn. Around the equinox of 2009, the two periods met and crossed over. The faster one became the slower one. Whatever sets the beat seems tied to sunlight falling on each pole. When the light shifts, the beat shifts with it. That is a strange way for a planet to keep time. Nobody has explained the swap. Almost all of Saturn's outer moons orbit the wrong way round. Of the dozens of small far moons on the books, most run backwards. Only a few travel with Saturn's spin, and the split is a clue rather than chance. Backwards orbits hold together further out. A body moving against the planet spends less time being strongly pulled by the sun, so it can sit at a greater distance and still stay. Orbits that run the right way out there are stripped off over billions of years. The ones left are the ones that happen to arrive backwards. They also fall into families that share much the same tilt, distance, and color. The big backwards family takes its names from Norse myth, and Phoebe is its largest member. The forward ones fall into two smaller groups, named for Inuit and Gallic figures. Each family looks like the rubble of one caught body that later broke apart. Their shared colors are the strongest sign of that, a record of old crashes. Saturn's day was finally measured using waves in the rings, not the planet. The rings work as an ear. Deep inside Saturn, the whole body rings like a bell, and its pull shifts a little as it does. Those shifts tug at ring bits at set radii. The bits pile up into spiral waves, cut into the ring itself. Cassini's cameras caught a set of these ridges in the inner rings. Read the pattern, and it gives the beat that made it. Match those beats against models of the inside, and the spin of the deep body drops out. The answer was 10 hours, 33 minutes, and about 38 seconds. It came from Cassini data, and it was set out in 2019. That is some minutes short of the old radio guess. The radio way failed, since the field is too even to give a clean beat, and Voyager and Cassini did not agree. The rings told us the time. There's a tiny moon inside the F-ring's core that seems to have survived being torn apart. Cassini imaged a small object embedded in the ring on a path that repeatedly crosses the densest material, and its orbit shifts in ways consistent with it grazing the ring. Bodies in this region sit near the limit where Saturn's tides overwhelm their own gravity. That makes them fragile, loosely bound piles of ice rather than solid rock, able to break up and reassemble. Some of the F-ring's bright clumps may be exactly that process caught in progress. The clearest case is an object first tracked in 2004. It crossed the ring core again and again. Its brightness swung wildly between passes, which is not how a solid lump behaves. It was never confirmed as a body at all. Possibly a dense clump. Whether anything out there is permanent is unknown, and the same object has not been convincingly recovered since. A moon that may not exist. The F-ring is braided, kinked, and rearranged on a timescale of weeks. It sits just outside the main system. The strand is only a few hundred kilometers wide, flanked by Prometheus on the inside and Pandora on the outside. Two shepherds, one restless thread. Prometheus swings out toward the strand on every lap, once every 15 hours or so. Each pass drags a dark channel through the ice. A streamer of stolen material trails behind it. The closest approaches come and go over about 17 years as the two orbits drift in and out of step. The damage tracks that cycle. Voyager saw features that looked platted. Cassini watched clumps form, brighten, and disappear. Some clumps behave like small solid bodies that build up and shatter again. Radio measurements found a core of larger chunks hidden inside the bright dust. Dust is only the smoke. No model reproduces the whole sequence. The fine structure remains among the least explained things in the system. Titan almost certainly hides an ocean of liquid water beneath its ice shell, and the evidence came from watching the moon flex. Cassini tracked tiny shifts in Titan's gravity field as Saturn pulled on it through each orbit. Titan swings closer in and then further out, and the squeeze changes as it goes. 6 close passes were enough. The moon deformed roughly 10 times more than solid rock and ice could manage. Only a global layer of liquid underneath lets a shell rise and fall like that. Radio measurements also found the surface rotating slightly out of step with the interior, which fits a crust floating free. The ocean may lie 50 kilometers down, or twice that. The same gravity data hint that the water is dense, so probably loaded with salt. Salty water would be sluggish and slow to mix, but estimates still disagree. Whether anything from that ocean ever reaches the surface is unknown, and no plume has ever been seen there. 2 habitable zones, 1 moon. Phosphorus was the last missing ingredient, and it turned up in data collected 20 years earlier. Nobody flew anywhere. Life as we know it needs phosphorus for DNA and for cell membranes. It sits in the molecule that carries energy inside every cell. Phosphorus is also scarce, which made it the weak link in the case for Enceladus. In 2023, a team reanalyzing Cassini's old ice grain spectra found sodium phosphate salts. The signal was unmistakable. Concentrations looked at least 100 times those of Earth's oceans. Only a handful of grains carried the salt, out of many thousands measured. The chemistry made sense, because the minerals expected on that seafloor release phosphate readily into salty water. Carbonate-rich water helps. Modeling had predicted the result before anyone went looking, which is unusual and worth saying plainly. The instrument was never designed for this kind of chemistry. It found it anyway. The measurement was always in the archive. Giovanni Domenico Cassini found the gap in Saturn's rings in 1675, working from Paris. His telescopes would look crude now, and no one could photograph anything yet. He also found 4 of Saturn's moons, beginning with Iapetus and then Rhea a year later. Tethys and Dione came more than a decade after that. The moons were the easy part. Iapetus handed him a puzzle, and he solved it without a better telescope. He could see the moon easily on one side of its orbit, and not on the other. The instrument was not at fault. He worked out that Iapetus must always keep the same face towards Saturn. That means we see one hemisphere from one side and the far one from the other. So one half of the moon had to be dark and the other half bright. He wrote it down and could go no further, since nothing then could resolve a surface. 3 centuries later, a spacecraft flew past and found exactly that. He had only his eye. Titan spends most of its life inside Saturn's magnetic shield, but not all of it. The moon orbits at roughly 20 times the radius of the planet, which puts it near the outer edge. When the solar wind gusts hard, it presses that boundary inward. The shield can shrink inside Titan's orbit and leave the moon standing outside in the open stream. Then the solar wind strikes the thick air with nothing in the way. Cassini flew through this happening. Its magnetometer found the field around Titan wearing the wrong shape, draped the way it drapes at Venus, not the way Saturn drapes it. The whole pattern had turned. Titan makes no magnetic field of its own, so it wears whatever streams past it. The shape of that draping is a fingerprint of the surroundings. That is how anyone could tell where the moon was standing. But such gusts blow through often enough. How often Titan is left out there is still poorly known. The harm is unmeasured. Dust ground off Saturn's backwards outer moons is what darkens Iapetus. The far small moons are struck all the time by tiny meteoroids. Each hit knocks fine dark grains loose. They form vast faint clouds that circle Saturn the wrong way. Sunlight slowly drags the smallest grains inward over long spans of time. Because those clouds run backwards while Iapetus moves forward, the dust hits its leading face head-on. The closing speed is high, and the grains stick. The grains are far smaller than a grain of sand, and they arrive dark. Iapetus moves at about 3 kilometers a second, and the dust comes the other way at a similar speed. They meet at roughly twice that, and nothing bounces off. Saturn keeps dozens of these backwards moons, most only a few kilometers wide, grinding each other down. The link is now widely accepted. How much comes from Phoebe rather than from its many smaller neighbors is not settled. One moon shedding onto another. Saturn's magnetic field lines up almost perfectly with its spin axis, and nobody knows why. Earth's field is tilted by about 11 degrees, Jupiter's by roughly 10. Saturn's tilt is under 1/10 of a degree. The standard dynamo picture says a field made by convection in a spinning fluid should not come out that even. A tilt is also what lets a field beat like a lighthouse, once per turn. Without one, there is no beat to time the day by, so the missing tilt cost us the rotation rate for decades. The field is also oddly weak for a planet this size. At the cloud tops, it runs near 1/5 of a Gauss, lower than Earth manages at its own surface, a world 9 times wider with a gentler field around it. Whatever smooths the tilt may be damping the strength as well. Cassini flew between the planet and the rings to look from close range and found no tilt, too tidy to explain. A moon 8 kilometers wide throws ring material a kilometer clear of the plane. Daphnis orbits inside the Keeler Gap, a narrow lane near the outer edge of the A-ring, and its path is very slightly tilted. Each pass tugs the gap walls sideways and upward. The result is a train of waves along both edges, crests trailing behind the moon and slowly relaxing back into line. Cassini caught them near equinox, when sunlight struck the rings almost edge-on, and anything standing above the plane cast a long shadow. The shadows gave the height. Crests reach roughly a kilometer up, in a disk that is itself only about 10 meters thick, so the sheet is being bent by 100 times its own depth. Daphnis also drags faint streamers of ice out of the walls behind it. Whether that material ever settles back is not clear. A ripple in ice. How bright the rings look depends on where the Sun and Earth happen to be. Composition matters less than geometry. Ring particles scatter light strongly back the way it came, an effect called opposition surge. When Saturn sits opposite the Sun from us, the whole disk jumps by tens of percent. Shadows hide behind their grains. Every particle shows its lit face at once. The surge is sharpest within a fraction of a degree of exact opposition. The window is narrow. But the same rule works in reverse from the far side. When a spacecraft looks back toward the Sun through the rings, forward scattering takes over, and the faint dusty rings glow like cobwebs. The E-ring appears. Cassini used that view to find rings nobody could see from Earth. Coarse ice and fine dust respond in opposite directions, so a single image at a known angle sorts the particle sizes. Brightness becomes a measurement. 2 views, 1 object. The haze that hides Titan is manufactured hundreds of kilometers up, and it falls like a slow orange snow. Sunlight and charged particles break nitrogen and methane into fragments that recombine into ever larger molecules. Cassini flew through the top of it. Its mass spectrometer counted heavy negative ions almost 1,000 kilometers above the ground, thousands of times the mass of a methane molecule. Everyone had assumed that region was nearly empty. Those grains grow, clump, and sink for decades before reaching the surface. Meters of the stuff may lie underfoot, so the ground is buried under a residue made by the sky above it. The haze also robs the surface of light and warmth, soaking up sunlight high above. The lower air ends up cooler than a clear sky would leave it. Benzene and propylene have both been picked out of the mixture. What the full inventory contains is guesswork. Instruments only see what they were designed to see. Enceladus is one of the brightest objects in the solar system, and the plume is why. Its surface is close to a mirror. It reflects more than 80% of the sunlight that reaches it. Fresh snow on Earth does about the same. And most old icy surfaces darken over time as radiation and dust work on them. This one does not, because it is being resurfaced from below. Snow from its own plume falls back and keeps the ground clean. The fall is gentle, a fraction of a millimeter a year across most of the moon. Near the South Pole it piles far deeper. Brightness this high needs grains that are clean as well as small. A consequence is that Enceladus is extremely cold, near 80 Kelvin. It absorbs almost nothing of what arrives. Sunlight there is already about 1/100th of what Earth gets. The moon is warm inside and mirror bright outside. William Herschel found Mimas and Enceladus in 1789 in the space of 3 weeks. He used a new telescope with a mirror about 4 feet across. It was the largest in the world, and it was hard to point. The tube was 40 feet long and swung on ropes and scaffolding. None of the work was easy. Enceladus came first, as a speck he could barely hold in view. The moons are small, only a few hundred kilometers across, right at the limit of what the mirror could gather. Mimas was fainter still. He gave them no names, only numbers. His son chose the names nearly 60 years later from the titans and giants of Greek myth. He was not looking at a world with an ocean, because nobody had that idea yet. But he was looking at a point of light that moved. 2 centuries later, Enceladus became the best place in the outer solar system to look for life. A speck and nothing more. Most of the gas inside Saturn's magnetic field is broken water. Radiation snaps water apart and the parts hold a charge. Oxygen and hydroxyl drift there, and so does whole water, and the whole mix is simply called the water group. No other planet runs on anything like this. Jupiter's field is full of sulfur and oxygen thrown out by a moon that never stops erupting. Earth's field holds hydrogen and oxygen leaking up out of our own air. The change is not just in the mix. Water group ions weigh 16 to 19 times what a proton weighs. Heavy things are hard to spin. The planet turns its field. The field tries to drag the gas round with it, and the gas lags behind. Out near the edge, that lag is wide and easy to see. It drags the field lines out until they thin and give way, where a lighter load would sit far more still, so the whole thing runs heavy. Counting Saturn's moons is hard, because there is no clear line between a moon and a rock. The confirmed tally keeps climbing. Most of the new ones are faint small moons a few kilometers wide, found by stacking many deep images to bring out a moving dot. One survey in early 2025 added 128 of them at once. That lifted the total to 274. No other planet comes close, and Jupiter sits well behind. An object has to be tracked across several seasons to prove it orbits Saturn rather than merely passing through. Many are lost before that happens and have to be found again. Proof is slow, and it is often late. Most of the new ones will never get a name. There is also no agreed lower size limit. The same lens power aimed at Saturn's rings, full of house-sized chunks, would deliver millions. So the number says as much about our tools as about Saturn. It will keep moving. Saturn stores up energy and lets it go in a giant storm about once a Saturn year. These eruptions are called the Great White Spots. They break out of the northern half and spread until white cloud wraps the whole planet. One arrived in late 2010, years earlier than expected. It grew until its tail met its own head, with a head thousands of kilometers wide within weeks. The mechanism seems to be water. Water vapor deep down is heavier than the hydrogen around it, so its weight holds convection shut. Heat builds under that lid for decades, then breaks through all at once. Cassini's radio antennas heard the lightning before the cloud was resolved, and the strokes ran far stronger than anything on Earth. The storm also warmed the air above it by tens of degrees. So the cycle resets. The gap is roughly 30 years, and why 2010 came early is unsettled. It builds, then it bursts. One narrow ringlet inside the rings always points at Titan. It sits in the inner C ring, an eccentric band whose long axis refuses to drift the way an ordinary orbits would. Instead, the axis keeps pace with Titan, far outside the ring system, so the ringlet's closest approach to Saturn stays aimed at that moon. The lock is a resonance. It fixes the orientation of a shape rather than the position of a particle, which is an odd thing for gravity to hold on to. Voyager found the pattern, and Cassini confirmed it had held for decades. Not every narrow ringlet works this way. The Maxwell ringlet, sitting in its own gap nearby, is eccentric too, but has no moon to blame, and it precesses freely as a single unit. Its own self-gravity is thought to bind the inner and outer edges together against the shear that should smear them apart. That balance is delicate. Models only reproduce it across a narrow range of ringlet mass. Narrow, stubborn, and aimed. Saturn is slowly eating its own rings. Charged water molecules from the ring plane spiral down magnetic field lines and fall into the upper atmosphere. The planet drinks its ice. Ultraviolet light splits the ice, and the charged fragments follow the field. Voyager saw dark bands in Saturn's haze that nobody could explain. Ground-based telescopes later tied those bands to the ring positions above them. Cassini's final dive sampled the falling material directly. Thousands of kilograms of ring ice reach Saturn every second. At that pace, the whole system drains in a few 100 million years at most. The instruments also found much more falling near the equator than any model had predicted. That flow is not charged and not steered by the field, so it seems to be dust simply raining inward. Gravity needs no help. The rate depends on how much sunlight is charging the ice, which changes with the seasons. So the drain is not steady. Whatever the ring's age, they will not last. Titan has seasons that last more than 7 Earth years each, and it is the only moon where the weather changes with them. Saturn takes about 29.5 years to circle the Sun, and Titan tilts along with it. The lean is about 26 degrees. Each pole gets a long summer and a long winter. Cassini stayed long enough to watch the turn. Clouds that had massed over the South Pole thinned out and reappeared in the north. A vast vortex of trace gases built up over the winter pole. Inside that vortex, the upper air cooled faster than any model had predicted. It went cold enough to freeze hydrogen cyanide into a cloud far above where clouds should form. That frozen cloud was the proof the vortex was real. The lakes did not visibly shrink or fill in that time, but a full Titan year of observation has never been completed. Half a season, at best. The strongest argument against life on Enceladus is not chemistry, it is time. Everything found so far establishes habitability. That means liquid water, an energy source, and the elements life needs. None of it establishes inhabitants. The gap is bridged only by history, and the history is uncertain. The ocean may not be old. Some models say the whole system heated up relatively recently. Estimates run from 100 million years down to a few tens of millions. That is brief compared with how long Earth took to show a biosphere. Other work argues for a long-lived ocean, sustained by the resonance with Dione. The disagreement turns on how fast tides drain a moon's orbital energy. Saturn may dissipate that energy far faster than once assumed, which shortens every timeline. Nobody knows which is right. A fly-through could carry an instrument that tests amino acids for handedness. Resolving it needs a mission designed for it. None is flying yet. Saturn was the edge of the known world for the whole of recorded history. Until 1781, it was the last planet, with nothing mapped beyond it. 5 planets moved against the stars, and Saturn moved slowest of the 5. It takes about 29.5 years to go once around the Sun. That is a human lifetime split into 2 or 3 slow passes. A watcher saw it crawl. It shifted about 12 degrees a year, one lazy step among the constellations. The Greeks called it Chronos, and that name got tangled up with their word for time. Rome called the planet Saturn, after an old god of sowing and of ages passing. Saturday is Saturn's day, and it is the only English weekday still holding a Roman name. So the slowest light in the sky is still in the calendar. Then Herschel found Uranus, and Saturn stopped being the boundary of anything. Saturn kept only the name. Cassini carried an antenna that listened to Saturn, and what it heard can be played back. The instrument picked up radio waves and waves running through the thin gas around the planet. Most of them sit far above hearing, so the pitch is shifted a long way down. Then they turn into whistles, long falling sweeps and a steady hiss, and some rise and chatter like birds at dawn. Others crackle, which is the static of lightning far below. It is worth being honest about what this is. The space around Saturn is close to empty, and empty space carries no sound. No microphone could have heard any of it. The antenna felt an electric wiggle, and the wiggle became a voltage, then a tone. What you hear is a translation, not a recording, and even so, the source is real. The loudest signals come from field lines above the aurora, where fast particles pour down. Those particles set the radio ringing, so the lights have a voice. Some of Saturn's small moons swap orbits with each other rather than crashing. Janus and Epimetheus ride on paths just 50 kilometers apart, and both moons are wider than that. Janus runs near 180 kilometers across, and Epimetheus near 120. It sounds like a sure crash, and it never happens. The inner one moves a little faster and catches up. As they close in, their own gravity trades orbit energy between them, so the caser is flung outward and the leader drops inward. They change places and part again without touching, roughly every 4 years. The swap is slow, not a sudden shove, and neither moon comes near touching. The lighter moon shifts much the further because it has less mass to move. For years, astronomers thought there was only one object there, and the reports of its place would not agree. Voyager settled it, so how this setup arose is still open, with a smashed single-parent moon the usual guess. 2 moons sharing one lane. Saturn's spin flattens it more than any other planet here. Its equatorial width is about 10% greater than its pole-to-pole height, a gap of thousands of kilometers. It shows in almost any decent telescope image, once you know to look for it. The cause is plain. The planet turns once in about 10.5 hours, and it is nearly 10 times the width of Earth. So material at the equator is thrown outward hard, and there is no rigid rock to hold the bulge in, only fluid. The flattening is useful as well as odd to look at. How much a planet deforms under its own spin depends on where its mass sits inside. A body with mass piled at the center resists more than one spread evenly. Cassini measured the sag in the gravity field to many decimal places. Those numbers are how we know the core is fuzzy at all. The shape is a window inward. Ultraviolet light from the sun splits the water ice on the ring particles. Each split releases oxygen and hydrogen, and the gas does not all settle back down. Some of it hangs above and below the disk, held loosely in place by Saturn's pull. So the rings have an atmosphere of their own, made from the rings themselves. Cassini carried instruments able to count single atoms, and they found the gas. Molecular oxygen showed up around the ring plane, along with a trace of hydrogen. The 2 gases do not stay together for long. Hydrogen is the lightest gas there is, and Saturn cannot hold on to it. It drifts off and is lost. Oxygen is heavier, so it lingers close to the ice that made it. The result is a faint ring of gas wrapped around a ring of ice. Thin barely covers it. This envelope is far emptier than anything we would call air, and a passing spacecraft would feel nothing at all. Nobody knows the rate. The main rings are lettered in order of discovery, not position. Working outward, the sequence runs D, C, B, A, then F, G, and the vast faint E ring. Nothing like a tidy alphabet. B and A came first because they are the obvious bright pair split by a dark lane. Any small telescope shows them. C was picked out later as a dim inner sheet, once called the crepe ring. D lies closer still, and it was reported from Earth in the 1960s before Voyager found a real ring somewhere else. The name outlived the mistake. The fainter outer members were assigned letters as instruments improved. Pioneer 11 picked out F in 1979. E and G were found by spacecraft. So the labeling is a fossil of observing history. It describes who looked, not what is there. Astronomers have kept it anyway. Renaming a system that appears in 2 centuries of papers would cost more than the confusion. Habit usually wins. Dragonfly will not drive on Titan, it will fly, and the thick air makes that easier than flying on Earth. A rotorcraft the size of a small car will hop between sites on 8 rotors. The air is 4 times denser than ours, and the gravity is 1/7 of it. A given blade lifts roughly 30 times what it could lift here. Each hop covers a handful of kilometers. Its power comes from a plutonium heat source, trickled into a battery between flights, because sunlight out at Saturn is far too feeble to fly on. The plan is dozens of hops over years, sampling dunes and icy plains. One target is a crater floor where liquid water and organics may once have mixed. Launch has slipped more than once. It now stands in 2028, with arrival at Titan in 2034. Every landing site is coarser on the maps than the craft is wide. Nobody knows what the ground will bear. It lands blind, every time. The plume was found by a magnetometer before any camera resolved it. Cassini flew past Enceladus 3 times in 2005. On the first passes, the instrument watching Saturn's magnetic field saw something odd. The field lines were bending around the moon, as if draped over an obstacle. Bare ice does not do that. The bend was small, a few degrees of deflection at most. A cloud of gas does bend a field, once sunlight and plasma turn some of it into ions. Ions grab the field. The effect ran strongest over the South Pole, which was the first clue about location, so the flight plan was changed. Controllers lowered the next pass to bring the spacecraft close to the source. Cameras then caught the plume against the dark, backlit by the sun. Infrared mapping found the warm stripes underneath. A mission arriving years later might have missed all of it. Southern summer was ending and the pole was still lit. Luck was part of it. Voyager 1 traded the rest of the outer solar system for one close pass at Titan. The flyby happened in November 1980, and the geometry was known well in advance. Passing that close to Titan meant a hard bend in the path. Titan's gravity threw the spacecraft up out of the plane the planets sit in. After that, there was nothing left in front of it to fly to. The tour was over at Saturn. Nobody was surprised by that, because Titan was rated the most valuable target in the system. Uranus and Neptune were handed to Voyager 2 instead, and it reached them years later. If the Titan pass had failed, Voyager 2 would have been sent to Titan as well. Then the 2 outer planets would have waited decades longer. The pictures came back as a smooth orange ball with almost nothing on it. But nobody at the time called it a bad trade. Titan was worth 2 planets. There is a proposed answer to why Saturn's field looks so tidy, and it points at the helium rain. Call it a candidate, not a finding. The idea starts with an old rule about how dynamos work. A churning fluid cannot keep making a field that is perfectly even about the spin axis. Something must be crooked down in the region where the field is made. If the outside looks straight, the crookedness is being hidden on the way out. The layer where helium settles out of the hydrogen could do the hiding. Material there sits in stable layers that resist moving up and down. A shell like that can turn at its own rate, faster or slower than the fluid below it. Anything lopsided gets smeared right around the planet as it passes through. Only the part that already circles the axis comes out the other side. It is a neat idea. It is also unproven, since nobody has measured the layer or its turning. Nobody has seen it at all. Tethys is cut by a canyon that runs most of the way around the moon. Ithaca Chasma is a trench a few kilometers deep and about 100 kilometers wide. It runs for thousands of kilometers, so following it takes you nearly all the way around. On the far side sits Odysseus, a crater 400 kilometers across. That is roughly 2/5 of the width of Tethys itself. Its rim has slumped. The floor now curves to match the shape of the moon, as though the ice sagged back into place. So the ice was warm and weak when that crater formed. One idea links the canyon to the same impact as a shock that split the far side. Another says the moon once held liquid water and freezing water swells. A growing interior would crack the frozen shell open along its whole length. Tethys is also less dense than water, which leaves almost no room for rock inside it. Nearly pure ice, and perhaps not packed solid. Neither story is settled. The planet leans about 27 degrees out of upright. That is close to Earth's lean, so Saturn has real seasons. But one trip around the sun takes about 29.5 years. One season, therefore, stretches past 7 Earth years before it turns. Summer arrives slowly. Sunlight creeps from one hemisphere to the other over decades, and the thick air answers years late. Cassini stayed in orbit long enough to watch one pole warm while the other slid into cold. Where the lean came from is not settled. A planet built from a flat disk of gas should end up nearly upright. One idea is a slow, steady tug from the orbit of Neptune, felt over billions of years. Another has Titan, drifting outward and dragging the spin axis over with it, which would mean Saturn is tilting even now. A big early impact is the third answer, and the hardest of them to test. The lean stands unexplained. Some ring waves are driven by Saturn itself, not by a moon. The C ring carries spiral patterns with no matching moon resonance. Saturn oscillates internally, and those pulsations pull rhythmically on ring particles at the right distance. The ring answers the beat. Each wave records the frequency of one mode inside the planet. That turns the disk into a seismometer wrapped around Saturn. The frequencies fit a deep interior that is layered rather than sharply divided, with a core smeared through much of the planet, not a clean rocky ball. Reading them required knowing where each wave sits to within a kilometer. Cassini watched stars set behind the rings for 13 years. Starlight passing through the disk supplied that precision. Wave amplitude also reports how much material the ring holds at that radius. So the same features weigh the disk locally. Which modes are excited and why some are strong is unsettled. A planet heard through its rings. Bright patches have appeared in Titan seas, held for a while, then vanished again. Cassini's radar looked at the same stretch of Ligea Mare on several passes across 4 years. A feature the size of a large island showed up in one pass, changed shape in the next, and had gone by a third. Radar sees roughness, not color. The liquid around it never moved. Nothing solid on Titan should behave that way, so every candidate on offer is something other than an island. One is waves, steep enough to throw the beam back. Another is nitrogen fizzing out of the methane as the sea warms, lifting a raft of bubbles to the top. A third is a floating crust of organic solids, soaking until it founders and sinks. Lab work has shown the bubbles are possible because nitrogen dissolves readily in very cold methane and comes back out when the mix warms. But no pass ever caught one forming. The name stuck anyway. Magic Islands, still unexplained. The ice grains are salty, and that is how the ocean touched rock. Cassini's dust analyzer read the composition of individual grains as they struck it. Most were nearly pure water ice. A minority, the heavier ones falling back near the moon, carried sodium chloride. Potassium salts and bicarbonate came with them. Ordinary table salt does not appear in ice unless liquid water dissolved it out of minerals first. So the water met rock. The concentration suggests an ocean about as salty as Earth's seas, or a little less. There's a wrinkle worth knowing. Telescopes on Earth looked for sodium in the vapor and found almost none. For a while, that argued against the salty sea. The resolution was that salt rides in grains, not in gas. Vapor boiling off a brine leaves the salt behind. The salty grains are also the biggest and the slowest, so most of them never escape. Only the frozen spray carries it out. Rhea may have rings, and the case for them came from counting electrons. In 2005, Cassini flew past the moon while its particle detectors were running. The count of high-energy electrons fell away steadily as the craft came in. Then it fell again on the way out, at the same distance on the other side. The pattern was a mirror image. Something in orbit around Rhea seemed to be soaking those electrons up. 3 years later, a team put that in print, and a moon with rings made headlines. It would have been the first moon anywhere known to hold one, so Cassini went back for a proper look with its cameras. It looked from the angles where faint dust shows up best, and found nothing. The pictures set a limit so low that any debris must be far thinner than the claim needs. The electron dips are still sitting there in the data. Nobody has explained them any other way. The ring stays unproven. A storm shaped like a hurricane sits right on top of the North Pole. It has a dark eye, a ring of tall cloud, and winds that never seem to let go. The hexagon frames it, and the cyclone spins inside that frame like a wheel in a socket. The South Pole holds one too. That southern storm is the stranger of the two because it has a true eye wall. An eye wall is a wall of cloud standing around a calm center. Before Cassini went there, nobody had ever seen one anywhere but Earth. The southern walls rise tens of kilometers above the eye and throw a shadow inward. On Earth, a hurricane needs warm motion, and it dies when it leaves the water. Saturn has no ocean and no coast, and these storms also refuse to wander. Earth's hurricanes drift, but both of Saturn's stay pinned to the poles for as long as anyone has looked. What holds them there is not agreed. Two eyes, both fixed. Titan has canyons half a kilometer deep with methane rivers still running along the bottom. Cassini's radar altimeter crossed a branching network of channels near the North Polar Sea and read back two things at once. The floors were dark and mirror flat, which is the signature of standing liquid. The walls above them rose steeply for hundreds of meters, in places beyond 500. So these are drowned gorges, cut deep and then flooded to the brim, joined to the sea and sitting at its level. Rain falls on hills of ice, gathers and cuts. Cutting that far down needs a very long time, or a fall in sea level, or a crust slowly rising. One radar track cannot say which. On Earth, a gorge like that means hard rock and a patient river. Titan's bedrock is water ice, and its river is methane. The altimeter beam is kilometers wide, so only the largest channels register. Everything narrower stays invisible. Methane in the plume is harder to explain than it looks. Cassini measured the gas mix while flying through, and methane came in at a few tenths of a percent. That is more than it sounds. Rock reacting with hot water does make methane on its own, with no biology involved. The process is called serpentinization, and it runs at Earth's vents too. One study ran the numbers as a formal probability problem. It compared the measured hydrogen, carbon dioxide, and methane against what rock chemistry can supply. Ratios matter more than amounts here. The abiotic root struggled to make that much methane at that rate. Microbes eating hydrogen would fit the figures more comfortably, but that is not a detection of anything. The result depends on assumed reaction rates and an assumed ocean size. Primordial methane, trapped when the moon formed and leaking out since, is also on the table. Clathrates could store it. The gas is real, and the accounting is not settled. Dion's bright wisps turned out to be tall cliffs rather than sheets of frost. Voyager saw pale streaks running right across the trailing side of the moon. At that distance, they looked soft and feathery, like something sprayed on. The obvious reading was frost, laid down by gas venting from cracks below. That held for 25 years. Then Cassini flew close, and the wisps broke apart into sharp, straight lines. Each pale streak is a wall of clean ice standing hundreds of meters tall. They line up along faults where the crust has pulled apart and dropped away. Fresh ice on a steep face stays bright because loose dust cannot settle there. So the brightness comes from slope, not from anything falling out of the sky. Cassini also weighed Dione by watching how its gravity tugged at the passing spacecraft. The pull fits a thick crust of ice floating on an ocean tens of kilometers deep. Nothing there moves today, as far as anyone can tell. Something once pulled it open. The top of Saturn's air is far hotter than sunlight can explain. Out at Saturn, the sun gives roughly 1/100th of the light we get. Yet the thin upper layers run hundreds of degrees warmer than that faint light allows. The gap is not marginal. Jupiter, Uranus, and Neptune all show the same problem, so it is not a Saturn quirk. Astronomers call it the energy crisis of the giant planets. One answer starts at the poles, where electric currents flow with the aurorae and currents make heat. The trouble is carrying that heat away from the poles and out towards the equator. A fast-spinning planet fights the spread, and models keep trapping the warmth where it began. Another answer comes from above, where grains and charged particles fall inward from the rings and dump their energy on arrival. Cassini measured the upper air on its final orbits by watching stars set behind it, so the cause is still argued. Warm where it should be cold. Titan's atmosphere spins far faster than the moon underneath it. The surface turns once every 16 days, while the winds high up circle the globe far faster. In the stratosphere, they pass 100 meters a second. That is a gale that never stops and never lands. Down at the ground, it is nearly calm, under a meter a second. The fast layer is decoupled from the surface it rides on. The whole sky slides over the ground. Huygens measured the whole profile on the way down by letting its radiotone drift. A sideways wind pushes the probe, the frequency shifts, and the descent becomes one long wind sounding. The channel meant to carry that measurement was the one never switched on. Radio telescopes on Earth locked onto the raw carrier tone instead, across 1 billion kilometers, and pulled the wind profile out anyway. One layer partway down came back oddly slow. Why the wind stall there is unsettled. The plume is far bigger than the moon, and a telescope near Earth measured it. In 2022, the James Webb Space Telescope looked at Enceladus in the infrared. Water has strong lines there. The vapor was visible because it glows at those wavelengths. Webb mapped it stretching about 10,000 kilometers from the moon. That is roughly 20 times the width of Enceladus itself. Ground-based attempts had only hinted at such a scale. Cassini flew through the dense part and could never step back to see the whole. Webb never left home. The map also caught the torus of vapor spread along the moon's orbit. Roughly a third of the water stays near Enceladus. The rest joins the wider system, feeding the ring in Saturn's upper atmosphere. A rate near 300 liters a second was reported. Some of Saturn's own water comes from this moon. One small moon wets a planet. 4 of Saturn's small moons ride 60 degrees ahead of or behind a larger one. Tellisto keeps station in front of Tethys, and Calypso trails the same distance behind it. Helene does the same work in front of Dione, with Polydeuces following behind. These balance points are called Lagrange points. Pull from the moon and pull from the planet balance there, so a small body can hold its ground. It is the same trick that parks swarms of asteroids along Jupiter's path. But no other planet is known to have moons doing this at all. Saturn has 4. They are only tens of kilometers across, dim, and very easy to miss. 3 were spotted from Earth in 1980, and Polydeuces stayed hidden until Cassini went looking. Helene is the largest of them, and its surface looks oddly smooth and dusty. Polydeuces also keeps its place badly, drifting far to one side and back over a couple of years. Why Saturn alone holds Trojan moons is not understood. The other planets kept none. Jupiter wears hard-edged stripes, and the ones on Saturn are soft and blurred. The same banded pattern is there on both planets, but on Saturn it is muffled. A thick haze is the reason. High above the clouds, sunlight breaks methane apart, and the pieces stick together as fine particles. Those particles settle into a deep layer of smog that covers the whole planet from pole to pole. Light bounces around inside that layer long before it ever reaches the cloud tops. It comes back out pale and even, like color seen through frosted glass, and cold makes it worse. Saturn sits nearly twice as far from the sun as Jupiter, so its clouds condense deeper down. Deeper clouds mean more gas and more haze stacked on top of them. Raw pictures of Saturn look almost blank, and the bands only appear once the contrast is stretched. In infrared light, where methane swallows the glare, the hidden belts snap back into view. Same weather, thicker curtain. Titan's air was discovered from Earth in 1944 from a smudge of light in a spectrograph. Gerard Kuiper split Titan's light apart from a Texas mountaintop and found 2 dark gaps in it at the exact infrared wavelengths methane swallows. Gas absorbs at fixed wavelengths. A bare, airless rock cannot make those lines, so something had to be sitting above the surface. He checked the other large moons and none of them showed the bands. Titan became the first moon known to hold an atmosphere. A Catalan astronomer had suspected it 36 years earlier from a fuzzy edge to the tiny disk, and almost nobody had believed him. Kuiper then put the pressure well below Earth's. But he was far too low because his method could only detect the methane, and methane is a trace gas there. The nitrogen that makes up almost all of Titan's air leaves next to no fingerprint in visible light. Voyager finally corrected the number. Iapetus is far too squashed for the speed at which it now turns. One spin takes about 79 days, which is extremely slow for a moon. A body turning that slowly should have settled into something close to a ball. Iapetus has not. Its middle stands out by tens of kilometers further than its poles do, measured from the center. That amount of flattening fits a moon spinning once in something like 16 hours, so the shape is a record of a much faster youth. Early on, the inside was warm and soft, and it settled into the form its spin demanded. Saturn's pole then dragged that spin down over a very long stretch of time. By then, the inside had frozen hard, and the bulge could not sink back. The timing is the awkward part of it. The moon had to be soft enough to relax, then stiff enough to stop changing. Both conditions are needed, and the window between them looks very narrow indeed. It remembers a faster day. The rings throw a shadow onto the planet, and the weather underneath feels it. Sunlight is already weak at Saturn, so losing part of it matters. Beneath the widest and densest ring, the shade is close to total. Where a gap runs through, light gets past in a bright stripe. Infrared maps show that whole pattern written out in temperature. Cool bands lie across the clouds exactly where the thick rings block the sun, and warmer lines sit under the gaps. The shadow is a picture of the rings, printed on the air below. It also moves. As the tilt swings through the long Saturn year, the shade slides from one hemisphere to the other. Near equinox, it narrows to a thin dark line along the equator. At other times, it lies broad across the whole winter half of the planet. The shading reaches higher than the clouds, thinning the charged layers far above them. So how deep into the weather it bites is still open, a cold print of the rings. Saturn's largest ring was found only in 2009, and nobody has ever seen it. An infrared space telescope picked it up by its faint warmth. The dust in the ring is very dark and throws back almost no sunlight. The sun still heats it, and warm dust glows at wavelengths our eyes cannot reach. So the ring shows up as heat, never as light. The scale is hard to hold. The inner edge sits millions of kilometers out from the planet. The outer edge lies far beyond that, well past every other ring anyone had mapped. It is deep as well, many times thicker from top to bottom than Saturn is wide. It is tilted too, standing at a steep angle to the bright rings. The dust is knocked off Phoebe by small impacts, then left drifting along its path. Spread through that much empty space, the grains lie a long way apart. A spacecraft could cross straight through the ring and notice nothing. The biggest ring hid longest. No probe has ever been dropped into Saturn. Jupiter got one. In 1995, Galileo released a small armored probe that fell in behind a heat shield. It lasted about an hour under the clouds and sent back numbers nobody could get from outside. Saturn never received the same gift, and its only entry was an ending. In 2017, Cassini turned into the atmosphere with no shield and no chance. Thrusters fought to hold the dish on Earth while the air tore at the spacecraft. Data flowed until the antenna slipped off target, which gave a taste of the very top of the air and nothing deeper. The great missing number is water. Water hides far below anything a telescope can see, and it records how much ice built the planet. Measure it, and you have a date and a birthplace. The noble gases stay hidden as well because they leave no mark in a spectrum. So the deep recipe is unread. Saturn has been alone since Cassini burned up in its atmosphere in 2017. Nothing has been there since, and nothing is on the way. That is nearly 9 years of an empty system, and the count keeps going. Dragonfly has not launched, and it does not reach Titan until the 2030s. It will study one moon. The rings, the plume, the storms, and the magnetic field all go unwatched. A mission to Enceladus has been drawn up and ranked more than once and never built. So the questions that need a spacecraft in orbit just wait their turn. Nobody can sample the plume again with instruments designed after anyone knew there was an ocean. Nobody can watch a whole season turn on Titan, or see how the storms come back. Everything new about Saturn now comes from telescopes here, or from Cassini stored data, read again by younger people. The archive is deep, and it is not endless. The planet goes round without us. That is where we will leave Saturn tonight. Everything we have talked about is still being worked out. The rings are being weighed again. The moons are being counted again. Somewhere in the data that came back from those last few orbits, there are almost certainly answers nobody has noticed yet, and someone will find them years from now, quietly, in a room with the lights on. None of that needs you awake for it. The planet has been turning like this for 4.5 billion years, and it will keep turning through the rest of tonight and through tomorrow, whether or not anyone is watching. The rings will thin, the ice will keep falling inward, and Saturn will go on being the strangest thing most people never look at twice. Sleep well, rest easy. We will go somewhere else next time.